Now for this question, a particle P is projected with speed 35 meters per second from a point O on a horizontal plane. In the subsequent motion, the horizontal and vertically upwards displacements of P from O are x meters and y meters respectively. The equation of the trajectory is y is equal to kx minus 1 plus k square into x square over 245, where k is a constant. P passes through the points A 14a and B 42 where a is a constant. Calculate the two possible values of k and hence show that the larger of the two possible angles of projection is 63.435 degrees, correct to 3 decimal places. For the larger angle of projection, calculate the time after projection when P passes through A, the speed and direction of motion of P when it passes through B. Okay, the best way to approach this problem is to draw a very detailed diagram. As you can see, the object is passing through A and B, where the coordinates of A is 14a, coordinates of B is 42 and 2a. We need to find the values of k. Here's the trajectory that's been given in the question. So I'm going to set up equations by substituting the coordinates into this equation. So we're going to take 14 and a, substitute here. The y coordinate is a, so the y here is going to become a is equal to kx, x is 14, so 14 minus 1 plus k square into 14 to the square divided by 245, and simplifying 14 squared divided by 245, you should be able to get 0.8 into 1 plus k square. And this is my first equation. Now for the second equation, I've got the y coordinate as 2a. So I'm going to say then 2a is equal to kx, sorry, x is 42, so 42k minus 1 plus k square times x to the square, which is 42 to the square, and all divided by 245. If you simplify this, use your calculator, you should be able to get 42 square over 245 as 7.2 into 1 plus k square. So what I can do now, I can divide this equation by 2 and I get a is equal to 21k minus 3.6 into 1 plus k squared. With equation 1, equation 2 can be equated, so we equate these and we get 14 minus 0.8 into 1 plus k square is equal to 14, okay, that should have been then 14k, I suppose. Sorry about that. Okay, 21k minus 3.6 into 1 plus k to the square. Simplifying further, this can come here. 3.6 into 1 plus k square minus 0.8 into 1 plus k square plus the 14k, and then this come here becomes minus 21k, and all of that should be equal to 0. 3.6 take away 0.8 should be able to get 2.8 into 1 plus k square, okay, minus 7k is equal to 0. This turns into a quadratic equation. So let us try and see. I can divide, if I want, by let's say 7. So this is going to become 0.4 into 1 plus k square minus k is equal to 0. And of course I've got 0.4 k square minus k plus 0.4 times 1 is 0.4 is equal to 0. And you multiply out by 10, so that becomes 4k square minus 10k plus 4 is equal to 0. I'll break this down by factoring, so you should be able to get 2k minus 1, 2k minus 4. Yes, 4 times 1 is 4, minus 4 times minus 1 is plus 4. That's okay. So 2k is equal to 1, 2k is equal to 4, meaning that k is equal to half and k is equal to 2. And here are the two values of k. Now, we also need to show that the angle for the larger value, for the larger of the two possible, the larger of the two possible angles, we need to prove that the larger of the two possible angles is, prove that the larger angle is approximately 63.435 degrees. Okay, so how are we going to do this? Alright, let us see. What I need to bring your attention to is that the trajectory is kx here in this equation. Now we've got the formula, which you should have in your book. And x is x, the coefficient is tan of theta is equal to k. So if tan of theta is equal to k, then I would say that theta is equal to the tan inverse of k. And for the larger value, we're going to take 2. That means further that theta is equal to tan inverse of 2. Check that out from the calculator. Okay, let's see here what we get. So tan inverse of 2, 63.4349. Okay, so I'm just getting this value here. Alright, so 63.4349 and so on. Therefore, that has been proved to be 63.435 degrees. It's been shown. The second part is asking us to find the time after projection when P passes A. Okay, when P passes through A, there, what is the horizontal velocity? I want to find the horizontal velocity. So let's call it Vx at A. Horizontal velocity at A is going to be equal to u cos of theta. And we know that a u is, let us see, 35, that's been given in the question, times the cos of 63 degrees, 0.435. So this is V meters per second. V meters per second. Here we are. Now, what can we do with that speed? The horizontal distance that's been traveled at that particular point is 14 meters. Okay, so we want to find the time. We know that time is equal to distance divided by speed. In other words, we're saying 14 divided by all of that. 35 cos of 63.435. So here we are. We're going to take the cos of the angle. So the cos of the angle is this much, and then you're going to take 14 divided by the result, and hang on a second, so 14 divided by 35 and then divided by cos of 63.435, and we're looking at 0.894, so 0.894 seconds. So here we are for the second part of the question. Now for the third part, we need to find the speed and direction of motion of P when it passes through B. We need to know what's happening here. Okay, now first of all I'm going to find the horizontal horizontal velocity. Let's call it VBX, and horizontal velocity would be then 35 cos of 63.435. Turns out to be 35 times the cos of 63.435 is 15.6, so 15.652 etc. meters per second. I also need the time it takes for the object to travel 42 meters. So the time is equal to the distance which is 42, divided by the speed, 15.652, and so on. So if we do that, it turns out to be 2.683 seconds. Now I also need the vertical velocity of the particle at B, which is then, let me just call it VBY. So that's going to be then 35, so in this direction now, doesn't contain the angle, so 35 sine of 63.435 plus GT, negative acceleration, and the time is 2.683, and so on. So what we have is then 35 sine of 63.435, turns out to be this much, and take away 26.83, and we've got 4.474. Alright, so 4.47496 and so on meters per second. Now that we've got the vertical and horizontal velocity, we can find the resultant velocity. I'm just going to call it VR, the resultant velocity of P at B here, and we're going to use Pythagoras theorem. So we can take the Vx and Vy, and so the square root of these two velocities, 15.6, 0.52 and so on, plus 4.474 to the square. So if I square it, and then I add to 15.652 to the square, it's 265. It's called VRB if you want. So 265.0104, and that turns out to be 16.3. So let's say a 16, it is 16.279 and so on. So that's approximately 16.3 meters per second. And for the direction of the particle, I just take the vertical step over the horizontal step. So the vertical velocity, so let's call it tan of beta, that's the direction, which then is going to be, the vertical velocity was found to be 4.47, so 4.474 and so on, divided by the horizontal velocity, 15.652 and so on. So let's do it. Let's take 4.474 divided by 15.652 and 0.2858 and so on. So the tan inverse of that is 15.95, which then turns out to be 15.952 and so on. So to two decimal places, the direction of the motion of the particle, the direction of the particle is going to be 15.95 degrees to two decimal places. Here we are for this question. Take care.